Hey, Algebra 2 Trig, welcome back. This is 1.6, Arithmetic Combinations of Functions. Go ahead and read and write the essential question. It's how do I perform arithmetic combinations when given two functions? Have some notes for you to take just for notation purposes. So go ahead and write that down if you can see it. Okay, it's also in your book if you need it. Okay, so let's start doing some problems. Alright, so example 1. I'm going to combine some problems, but example 1 will be let f of x equal x plus 3. Oops, forget that parentheses, sorry. And g of x equal x squared plus 2x minus 3. So part A will find f of x plus g of x. Part B, we are going to find, and I'll write it in a different notation just to mix it up, f minus g of x. F of x minus g of x. And then part C, we are going to find f of x times g of x. Okay, and I think it's pretty self-explanatory, but the first one, I'm literally just going to add the two functions. Okay. So when I add the two functions, all I need to do is make sure I combine like terms. Make sure you don't multiply it because there is a plus sign in between. So the answer is x squared plus 3x, and then plus 0, obviously, but I'm not going to write that. Okay, for f minus g of x, I have to make sure I write it in the right order, so I distribute the correct sign. So I know it's x plus 3 minus x squared plus 2x minus 3. And I will have to distribute this negative sign to each of the second parentheses. So minus x squared minus 2x plus 3. Then I combine like terms. I want to make sure I did this right. Ooh, I wrote the first part right. It was x plus 3. So now if I combine like terms, it'll be x squared minus x plus 6. Sorry. I'm trying to do this at 4 in the morning, so it's kind of difficult. Alright, last one. F of x times g of x. So I know that I have to multiply. So x plus 3, x squared plus 2x minus 3. And depending on how you multiply, you can multiply each term. So I can multiply each of the first term by the first 3. Then I can multiply the second term by the second 3. Or like Mr. Doan said, you could draw a 2 by 3 box. Whichever way you want to organize it. So you draw a 2 by 3 box, and I know it's x and 3. X squared 2x minus 3. And then if I multiply it correctly and combine the like terms, I should end up with x cubed plus 5x squared plus 3x minus 9. Okay? Don't worry about factoring any of these problems. We are just adding and multiplying them, adding, subtracting, and multiplying, so I'm not concerned about multiplying. Okay? Alright, let's move on to the next example. Okay, so for the next example, we are going to divide. So we are going to find f of x over g of x, given that f of x is x squared plus 2x plus 4, and g of x equals the square root of x squared minus 16. Okay, so if I look at this, if I'm dividing, I'm literally just going to put it over each other. So I'll write in another notation. F of x over g of x is x squared plus 2x plus 4 divided by the square root of x squared minus 16. Okay, so what I want to say with all these problems is, with all these problems, you have to consider the domain. So you have to consider the domain. Well, the reason why I didn't really go over domain in the first three is because everything has been all real numbers, because they're all polynomials. So this is a polynomial, this is a polynomial, this is a polynomial. What I multiplied and added were polynomials, so I don't really have to worry about the domain. Now with this problem, I will have to worry about the domain a little bit. Okay, so I know I can't divide by 0 on the bottom. I also know that the square root can't be a negative. And if I look at the top is just a polynomial. Okay, so let's consider the domain. So the domain for the top should be all real numbers, or from negative infinity to infinity, however you want to write it. The domain for this, however, is a little different. So for this, you might have to look at this analytically. I know if this number is smaller than 16, it'll be negative, so that can't happen. And I know if this is 16, if x squared is 16, then 16 minus 16 is 0, and I can take the square root of 0, but I can't divide by 0. So therefore, I know x has to be greater than 4. Okay, I know, and it can't be equal to 4. I also know that x has to be less than negative 4. Okay, so I know these are my two domains, and what the important thing is, I need to find the intersection of the two domains. So if I look at a number line, and I consider this domain is all real numbers, meaning it's every number between here and here. Well, the domain for this one is it has to be greater than 4, and it has to be less than negative 4. So when I say the intersection is which parts do both of these domains cover? Well, I know since this is all real numbers, I'm just going to consider this as a domain. So your domain is going to be it's going to be x is greater than 4 and x is less than negative 4. If you have any questions, write it down and we will answer it tomorrow.